Hey, good day. Happy day. I'll be back tomorrow for PLT. Unfortunately, James was running a fever last night. I think he might have another ear infection, so I'm not going to be there. It's all right. We'll be fine. We'll be back. You guys are going to be all right. It's a little introductory to this unit. Something you've kind of seen before already, so it shouldn't be too bad. Okay. I am going to check these tomorrow, these notes, so make sure you're taking good notes. First change I want to make, it says Unit 11 again, but this is not Unit 11. It's Unit 12. So please make that change for yourself. All right, write 12. I don't know what happened. We put Unit 12 and then it said Unit 11, or maybe we didn't put Unit 12 at all, but that's all right. Okay, so we're going to do things a little bit differently as far as the notes go. All right, obviously, so I don't have my what do you call it? I don't have my laptop at home, so I can't use. I don't have my iPad at home, so I can't use my iPad to make a video. So I'm just going to use some old notes, and we're just going to go through it that way, and then we'll be fine. All right, we'll be fine. Okay. All right, let's go. Oops. What did I just do? Okay. So first of all, talking about ratios. Okay, ratios. What are ratios? Well, ratios are a fraction that compares a part to a whole, or a part to a part. So this was a notes from last year in one of my classes. The ratio of Lake Forest to Lake Bluff residents was 15-2. Ratios can be written as fractions, or you can see them as with this little 15:2. All right, one of those. Those are two representations for it. Okay. What happens when we have two equal ratios? All right. Well, two equal or equivalent ratios, a lot of times we'll call those proportions. Okay. Proportions when you have an equal sign like that. To find a ratio that is equivalent to 2/3, set those two ratios equal to each other and take a look, aka cross multiplication. So I made this example of 2/3. Well, 4/6. Are these equal? I'll cross multiply, meaning 2 times 6, and 4 times 3. Hey, 12 is equal to 12. Those are two equivalent ratios. All right, this is just review from an Algebra 1 skill. Okay, this is review as well, but this skill is going to come up a lot this unit. All right, this skill that I'm pointing to right here. Okay, with my mouse. All right, the x over 3 or x minus 3 over 2 equals 8/9. Cross multiply, I get that. 9 times x minus 3 equals 2 times 8. Now, some of us may be able to just write right here 16, and that's fine. This step, however, is helpful to write as 9 times x minus 3 because we have to remember to distribute that 9. All right. Again, this is a review of a skill that you've learned before. Okay, and then just from there, you solve it using algebra. Same idea here, another cross multiplication. 5 times x minus 14 equals 9 times x, or 9x. Okay, we're going to skip those. This is the core concept of the day. All right, corresponding parts of similar polygons. So there's these things called similar shapes. Okay, they can be similar triangles. You can have similar figures, similar polygons in general. All right. How we write that, the symbol for similar is right here. Okay, the symbol for similar is right here. It's a single squiggle like that. All right, that's that similarity symbol. Okay. This says in diagram below, ABC is similar to triangle DEF, meaning yada, yada, yada. Using here is the similarity statement here. That's how we would write that. Similarity transform preserves angle measure. So what it's saying is the corresponding angles are congruent. The sides have a common ratio. All right, the ratio of the corresponding side lengths. So similarity either enlarges or reduces a shape. Okay, and that's by a scale factor. We call that scale factor K. So corresponding side lengths are proportional. Okay, meaning their ratios are equivalent. What do I mean? Well, DE over AB is going to be the same as EF over BC. Like those ratios should be equal if these shapes are similar. The angles are always going to be the same. Angle A will match up with angle D. All right, angle B will match up with angle C, and then, or excuse me, B with E, C with F. Okay, we'll talk more about that. Corresponding side lengths of similar figures. If two polygons are similar, the ratio of the two corresponding side lengths is equal to the scale factor. All right, so what does that mean? So if I tell you that triangle ABC here is similar to triangle AED. So ABC is the larger triangle, AED is the smaller triangle. All right, that means, well, AB, the first two letters here, okay, that is going to have the same ratio, or AB over AE is going to be the same as BC over ED. Here's what I'm talking about, okay? The order of the letters matters. So if you look at your similarity statement, ABC to AED, AB are the first two, AE are the first two here. BC are the second two, so that matches up with ED here. Just pay attention to the order of the letters in your similarity statement. Here, 10 over 4 equals 5 over 2. All right, so where did I get 10 from? Here we go. 10 is this whole side here, so AB is 10. 4 is AE. 4 is AE. Okay, this whole side AB, which is 10, and then 5, so the big triangle 5 goes to 2. It'll make more sense, I promise. The perimeters of the polygons are going to be like, it says if two polygons are similar, the ratio of their perimeters is equal to the ratio of their corresponding side lengths. Okay, so if I said these two shapes, if these two sides were 2 and 3, their perimeters would be the same. Let's say the perimeter here was 20 and the perimeter here was 30. Well, guess what? If I reduce 20 over 30, I get 2 over 3. All right, the perimeters are going to come down to the ratio of the sides. They'll always be equal. Area is a little bit different. Okay, area is different. Remember, perimeter is just adding sides, right? Adding sides together. So the ratios of the perimeter is going to be equal to the ratio of the sides. Area is different because we're multiplying things. Well, remember, area is units squared. So the ratio of the areas is equal to the squares of their corresponding side lengths. So if I ask you, hey, what's the ratio of the areas here? Well, if the two sides were 2 and 3 again, the area ratio would be 4 over 9. 2 over 3 squared, 2 squared is 4, 3 squared is 9. Extra practice. Here we go. Here's the fun stuff. So we want to set up a proportion here. Okay, a fraction equal to a fraction. And we're going to do this. A lot of this unit is solving for missing sides in similar shapes or missing angles in similar shapes. All right. First one on the right, number 1. What corresponds with 2? 2 corresponds with 3. X corresponds with 7. Now your proportion, like the order matters, okay? So you have to stay consistent. I say it a lot, stay consistent. Like I could say 2 over 3 equals X over 7. I could say X, that's an X, it's hard to write with the mouse here, X over 2 equals 7 over 3. You could say 3 over 2 equals 7 over X. You have to stay consistent. All right, I have to stay consistent. Like these two things here correspond with these two. 2 corresponds with 3. X corresponds with 7. I can go big to small. In this first example down here, all right, in the red, I went small to big. 2 to 3 equals small to big. X to 7. And then I cross multiplied. 2 times 7 is 14. 3 times X is 3X, and I got 14 over 3, and that's okay. Or you can get the decimal, okay? Stay consistent. Small. I like to go small to big, small to big. If you want to do 2 over or x over 2 equals 7 over 3, that's fine. Just match up those corresponding parts. Here, this is a little bit different. I need to solve the value of x. All right. Notice how those angles are marked. They're marked like that for a reason. Okay. Well, what corresponds with the 30? The 30 corresponds to the side that's across from the angle with the single tick mark. So 30 corresponds to 12. What corresponds to 25? 25 is across from the angle with 2. So 25 corresponds to x. And lastly, 8 is across from the angle with 3 tick marks. So 8 corresponds to 20. Now I can set this up different ways, but no matter what, I want to solve for x, right? So I'm going to say 25 over x, so left to right, big to small, equals 30 over 12. Now I know what you're thinking. Hey, couldn't I said 25 over x? Man, it's hard to write with the mouse. Holy buckets. Here we go. 25 over x equals 20. Wow. Wow, that's good. Over 8. Yeah, you could do that too, and you would, guess what? You would still get the same answer. All right, you would still get the same answer. I can promise you that. Because 25 times 8 is 200 equals 20x. X is still going to be 10. You have to stay consistent, though. I can't say this. This is what I cannot do. All right, I cannot do this. I cannot go, all right, 25 over what? What does 25 not correspond with? I can't go 25 over x. Here, I got this. Guess what? I got this one. So left to right equals 12 over 30. That's a common mistake a lot of people make, and then they go right to left. You got to stay consistent. 25 over x left to right and equals 30 over 12. This is not allowed. Don't do this. Don't do that. Okay? Find the scale factor from A, B, C, D, E to K, L, M, N, O, P. Wow. Well, line up the corresponding sides. It says these two shapes are similar. So AB matches up with KL. 2 to 3. KL matches up with AB. 3 to 2. Find the values of x, y, and z. Well, the first one I'm going to do is find the value of z. I think that's the easiest. Why is that the easiest? Well, angles are always the same. So z is angle A. Angle A matches up with angle K. And angle K is 45. So z is 45. Let's solve for x. What does BC match with? BC, you can look at the picture, you can look at the letters. BC matches with LM. Whoops. So 1 over x, and then I'm going to use that ratio, 2 over 3. Because I know 2 and 3. I know DE and NP, 2 and 3. That's something that I know, and then I'm going to cross multiply and solve and get 1.5. If I want to solve for y, y matches up with AE. Again, I'm going to use 2 over 3 again. Okay, I'm going to use 2 over 3. So I'm going to go, I'm a left to right person. Okay, whoops. So I'm going to say, hey, 3 root 2 over y equals 2 over 3. Left to right, left to right. Cross multiply. Okay, I get 2y equals 9 root 2, and then I divided both sides by 2 to get 4.5 root 2. Find the ratio of the perimeters. Well, the ratio of our perimeters are equal to the ratio of the holy buckets. What's going on here? Oh my goodness. There we go. It's equal to the ratio of the sides, so it's just 2 to 3. In the areas, I just square that ratio. So 2 squared over 3 squared, which is 4 over 9. All right, these two we'll do together, and I'll give you a recap on Thursday as well. If this was a struggle for you, please come see me tomorrow on PLT. I will be there. Have a great rest of your day. Make sure you took good notes. If you're still listening, put a smiley face over the 6.